Next topic, very interesting topic. Some other methods that you'll find extremely useful to understand when using streams in general, as well as for your programming assignment. And that's going to be filter and flatMap. These are both stateless run to completion operations. So what does filter do? It tests a predicate, remember a predicate's a functional interface, against each element of an input stream, and it returns an output stream that only contains elements that match that particular predicate. So it's used to basically filter things that match. As a consequence, the number of elements in the output stream may be less than the number of elements in the input stream. It all depends on whether they were matched or not. If they match, they come out. If they all match, the same input stream had n elements, output stream has n elements. If some of them don't match, then the input stream had n elements and the output stream has m elements, where m is less than n. So if you don't get a match, it doesn't come out, basically. So here's an example of how we use it. After we convert things to search results, if for some reason there were no hits at all, if you got back an empty search result with a count of 0, in that case we would get rid of them, so we'd only have the ones that were non-empty continuing on to the next phase. There's no sense keeping around stuff that doesn't have any values. Very important thing to remember. Filter cannot change the type or the value of the elements that it processes. It can only decide to include it in the output stream or not, but it can't change anything. So the value isn't changed, the type isn't changed. It either includes it or it doesn't. Here's the use of filter in context. You can see what we're doing here is we're saying for each search result, if it's empty, and we negate that, so that would mean it's not empty, only allow things that are not empty. That's the way to read this. Very declarative, says filter stuff that's not empty. That's the great thing about streams, by the way. You can, once you get used to this sort of fluent model and the syntax, you can just kind of read it from top to bottom. You don't have to sit there and loop. You don't have to sit there and branch, per se. That reminds me, it is okay to use the question mark colon operator, the ternary operator, in the context of your program. And most likely the place you would use the ternary operator will be in map to int. Now you can also use an if-else statement there as well, but I think when you look at it syntactically, it's a lot more visually jarring to use if-else because you have to put open curly brace and you have to return and all this stuff. If you use the question mark colon operator, the ternary operator, it's just a little cleaner, but you're welcome to do either way. Oh, great question. So the way the program was set up, so to repeat the question was how does it know what it's looking for, what it's looking at, right? It knows what it's looking for, it's the words. How does it know what it's looking for the words in? And there was an input string. So the way the program worked, if you go back to the earlier discussion, it reads a file that contains the input we want to search, which in this case with the lyrics to the Do Re Mi song. It puts that into a string, and then it goes ahead and it uses that string, and all the searching that's taking place here is in the context of that string. It's stored in the object. So the object where this little stream is running would just have that as a field, and so it knows it can go reference it. There would be other ways to do it as well, but that's the clean way to do it here. Great question. Next operation. This is a really interesting one, and this one, very, very powerful, a little bit more complicated to understand, but you will find it will save your bacon over and over again. And it's called the flatMap operation. And what's interesting about this is when you first read it, you're like, how the heck does that differ from map? So here's the description. Returns a stream that replaces each element of this stream with the contents of a map stream produced by applying the provided mapping function to each element. So that's what it says. And when you first look at this, you're like, that sounds just like map. But it's not like map. And here's probably the easiest way to realize it's not like map. The number of output stream elements produced by flatMap doesn't have to equal the number of input elements. Remember, map has the constraint that it has to be the same. Number of input elements, number of output elements. flatMap says it could be the same, but more likely it'll either be more or it could be less. And I'll talk about each of these situations here with some examples. So here's a very simple example. Let's say that we have a bunch of lists of strings. So for sake of argument, let's say that we have we have different lists of strings, and each list corresponds to different groups of characters in the play Hamlet. So some of the first list might be, royalty characters. So we would have Hamlet, the father, and Hamlet, the son, and we might have Fortinbras, the father, and Fortinbras, the son, right? Those would be royalty characters. And then we might have other characters that are like comedians. So the grave diggers, for example, they would be comedians. Or alas, poor Yorick, right? He was a comedian, so he's another. So maybe we'd have a list of characters that were comedians. We might have a list of characters who are courtiers, like Laertes or Polonius, or perhaps Horatio, depending on how you look at his character. So you might have a bunch of lists of strings. And so we could come along and we could say, stream of list 1, list 2, list 3, ... list n. So we might have 7 different categories of characters in the play Hamlet. And we could pass that to stream of. And that would produce a stream of lists of characters. But that's still somewhat unwieldy, right? I'm trying to imagine doing searches through lists of strings, blah, blah, blah. So instead what we can do is we can apply the flatMap operation, and we can say, take each of those lists of strings and flatten them into a stream of strings. That's why I always show a little steamroller when I talk about flatMap, right? It's flattening it out. So what you would end up there would be a stream of strings, which would then, kind of merge all those different groups of characters together into a stream. And then we could do stuff to them. Like map, flatMap may transform the types of the elements it processes. Doesn't have to, but it could. And then here's kind of the example I just showed you. We could have a bunch of lists of strings with different characters in Hamlet or whatever. And then down here we would create a stream of lists of strings using of, and then we would apply flatMap with the list : stream operator, which says flatten those things to make ourselves a stream of those strings. And you can play around with this example if you're so inclined here in my EX12 folder. So that's the end of our discussion of Java streams, intermediate operations, filter, flatMap, and so on.